Hello and welcome back to my channel guys. Today we are going to see loads and their classifications. We can classify these loads into two different manners. One according to their application and another according to effect they produce. So as you see, according to their application, there are 7 types of loads can be defined. One is a dead load, another is a live load, wind load, seismic load, temperature load, impact load and erection load. If you see this building as an example, so this building has a roof and 3 floors including the ground floor. So roof is a dead load, snow on the roof is a live load, and the walls, the ceiling are considered as a dead loads, but human and furniture we can consider as a live load. There is another erection load which is called a soil load plus hydraulic load, which is come due to the water into the ground. Now we will see what are the other loads. So the next one is wind load. So if you consider this as a building and wind is coming from this direction, so it generates the effect on the building at the other portion of the building. So this is a ground, and you can see as the distance from the ground to the topmost point of the building increases, the wind load also increases step by step. So this is a wind load. Then the next load is a seismic load, which occurs due to the earth pressure, or you can say the earthquakes. So this is called a seismic load. Temperature load is caused because in the summer, when the building temperature increases, or some structural components which are very close to the furnaces and very heat generating elements, those also get affected with the heat load. Another one is the impact load. This figure all of you must have recognized. There is a shaft. This is a moving load in the shaft, and this is a collar of the shaft. H is the distance between the load and the collar. L is the length of the shaft, and delta L is a deflection in a shaft. When this load is get impacted on this collar from some certain distance which called height, it get deflected, or you can say elongated. This shaft has been get elongated by this delta L length. So these are the types of different loads we have covered. So another classification according to effect loads are producing we will see here. We have taken a square specimen to check the various effects of the load. The variety of loads acting on the structural member producing different types of effects. So what are those effects? We will see. For convenience, these forces are resolved into components. They are normal and tangible. So some normal and tangible forces are acting in the cross section. The origin of the reference axis is always taken at the centroid of the cross section. Each of these components have different structural effect and produces different structural deformations in the specimen. So in this figure, we will understand what are those effects. So some effects which is called axial forces are acting on this body. So here we will see some axial forces are acting on the body. Fy and Fz are considered as a shear force on the body. Mx, which is a torsion moment coming on the body, and My and Mz are bending moment. Now we will understand all these 4 forces, how they are acting. Here we will see a various components. First is a Fx, which is an axial force. You can see in this specimen, if the internal forces are coming into these directions, we will call them as a positive axial force. If the forces are acting as a compression on the body, we will call them negative axial force. So in the axial force, we have learned the force acting normal to the cross section. So this is a cross section, and the force acting normal to the cross section and passing through its center is called an axial force. The primary effect of axial force is to change the length of a member. So in this figure we have seen that if these forces are acting into this direction or into the reverse, in the both way, the length is going to change from L to delta L. Axial force may be tensile in nature, which cause increase in length of the member, or compressive in nature, which is also decrease in the length of a member. So force can be defined by sigma into A, which is shear stress multiplied by the area on which the shear stress is coming. So this is a Fx force, which is axial force. Now we will see Fy and Fz, which is called a shear force. This square specimen is going to have some shear force in the body. We have taken this as a cross section of the member. Now some forces are acting from downside and some are from upside. So in this case we call them as a positive shear force. And when these forces acting in opposite direction, we call them negative shear force. Shear force can be defined by load upon area. So load which is we have applied on the body. So if you consider this load, we have applied a 10 kg on the body, that will call as a F. And the area which we have called, this is a cross section area of the specimen, that we have called a area on which the force has been applied. So in shear force, the force acting tangential to the cross section is called a shear force. In this diagram we have seen, this is a cross section and the force is acting tangential to the plane, or you can say cross section, is called a shear force. The primary effect of these forces is to cause sliding of one cross section with respect to another. So this cross section, or you can say this side of the specimen and this side of the specimen, is actually getting shear here due to the shear forces. So actually it shears the member, that's why they call shear force in the diagram. So this is a shear forces. Next we will see Mx, which is a torsion moment. Here you will see the Mx, which is actually acting as a torsion moment in the body. If the specimen has been considered as a fix at one end and the torsion has been applied from other end, then you can consider, or you can understand this, what exactly the torsion force is. In this figure we have tried to explain this with the round bar. So here at this end the round bar is fixed at one end and the torsion is getting applied into the other end. Theta is actually making the angle in between the molecule. If we have applied the torsion T here, this molecule is going to get twisted due to the torsion moment up to this point, and the angle between those points we have considered as an theta. We can explain this in more detail with this cross section taken. So here you will see this is a shaft cross section and this is the center of the specimen. Here the torsion T is getting applied on the body. Now what happened exactly? The molecule at the farthest end of the specimen is going to get twisted up to this point. So which we can call, with this radius, the molecule get twisting moment from this point to this point. So easily you can understand that torsion T is getting increased as per the radius is getting increased. Now the formula is torsion tau equals to T into R upon J. So T is nothing but the torque applied on the body. R is the radius from the center of the specimen to the farthest position of the molecule. J is nothing but the section modulus. So J can be defined by pi into D raised to 4 upon 32, which is for the solid rod. Now we can see the net moment vector acting on normal to the cross section is called the torsion moment. So the vector acting normal to the cross section, so which is called as a torsion moment or torque. So if you consider this is a point, center point of the specimen, and torque applied on the body, which you call a T in this figure, which is creating a torsion moment. The primary effect of torsional moment is to cause rotation of different cross sections, because you can see easily, if I take a cross section here, then the molecule moment is small. If I take a cross section at the end, the molecule moment is bigger. So the primary effect of torsion moment is to cause rotation of different cross sections of member with respect to each other about polar axis. This rotation is called a twist. So the molecule at this point, when transferred to this point or travel a distance up to this point, which is called a twist in the job. So this is a torsion moment. Next one is a bending moment. Let's understand the bending moment. So some forces are acting on the body from this direction, creating a concave or convex moment in the specimen. How that we will understand now. So the bending moment formula is load into length. So load acting on the body is from particular distance and which has a length from the particular point is called a bending moment in the body. So bending moment can be at the positive direction bending moment and negative direction bending moment. So in the positive you can say a specimen forming a shape as a concave, and in negative bending it's forming a shape in a convex manner. So net movement vector acting tangential to the cross section. So the definition of bending moment is net moment vector acting tangential to the cross section is called a bending moment. So at this point we are taking a cross section and it is acting tangential to the cross section of the specimen, which is called a bending moment in the body. These moments cause bending of the member at the rate and axial parallel to the cross section. Axial parallel to the cross section, and ultimately produce slopes and deflection in the body. So you can consider this can be an individual load if it is acting individually, and there are the combination of loads coming on the body from all directions, which we are calling a strength of a material. So this way guys, we have explained here how the different kind of loads acting on the body, and according to their application, how the classification in the loads has been done. So what we have learned, we will quickly revise here. So there are two classifications according to their application and according to their effects they are producing. So according to their application, there is a dead load, live load, wind load, seismic load, temperature load, impact load and erection load. And according to their effect they are producing is axial load, shear force, torsion moment and bending moment they are producing in the member. So this is the end of this chapter guys. Thank you very much for joining us. Please like and subscribe to our video. Hit the bell icon button so you can get a notification of a new video on time.